right, in this module, we're going to talk about functions. And I've broken the topic up into 4 sections. The first one is really what a function is, which we'll talk about. The second is why is it useful to use. The third will be how do we create them in Swift. So we'll go through the specific syntax of creating functions. And then finally, how do we actually call a function. So first, I thought I'd start out with the concept of a recipe. So you can imagine a grilled cheese sandwich recipe having all of these steps that it's going to go through to actually make a grilled cheese sandwich. And when we think about this recipe, we can also think about the fact that it has inputs. So it has something that comes in, and then we follow the recipe, and then of course it has outputs as well. So we might ask the class at this point, what do we think the inputs would be for this recipe? So it could be maybe that's the cheese, it's the bread, it needs butter, but the common inputs that you might think of for this are going to be 2 slices of bread, cheese, and butter. Those would be correct answers. Those would be the inputs to this recipe. And then the question is, what are the outputs? So that's kind of pretty obvious. We're making a grilled cheese sandwich, so the output is a grilled cheese sandwich. So as I think about this recipe, I want to kind of make an analogy to actually making this recipe over and over again by a bunch of different people coming into a kitchen to do it. So what I have here is basically this kitchen, and what we're going to do is look at the fact that there are multiple people coming into the kitchen. Let's say it's around lunchtime, and they want to make grilled cheese sandwiches. And so each of them in this case has a copy of the recipe for the grilled cheese sandwich. And so you might think, well, okay, that works, but it's potentially a little bit impractical because, for example, I've had to make copies of that recipe and give it to each of the individuals. And so now they all have an extra sheet of paper and they have an extra set of instructions that they have to follow. Wouldn't it be easier if we actually took like a Post-it note or we took our actual recipe and put it up on the wall and put a thumbtack in it and it was there for everybody to see? And so that's what I want you to think about when you think about functions, and we'll kind of reinforce this as we go through this little presentation, is that what we've done is we've taken that recipe and we've made it common and public to everybody and put it up on the wall. So when people come in to make their grilled cheese sandwich, they don't need to have a copy of the recipe. They can just go to the wall and they can see the recipe right there and follow the directions. And of course, they're each going to supply their own set of inputs. So even though there's a single recipe, this person who's going to make that grilled cheese sandwich has got to still supply the cheese and the sandwich and the butter, and ultimately is still going to get their own output, which is their own grilled cheese sandwich. So let's look at how we define a function in Swift. So again, we want to think about the fact that this is a common recipe that's going to be followed over and over again by many people. And when you see that type of pattern, you should think, I probably want to make that a function. I don't want copies of the same thing all over my code. I want to consolidate it all in one place, put it up on a wall, put a thumbtack on it, and allow everybody that needs to perform that function see it and have a common spot for it. So this is our analogy of how we go from a recipe to a function. So we'll look at some examples of that in the code. So let's look first at how we actually declare a function in Swift or define a function. So here we have an example, and I've got the whole syntax here of the function, and let's just step through it step by step. So first we have a keyword called func, F-U-N-C. It's short for function, and that's what we're going to always start with when we declare a function. We're always going to start with that keyword. Now, if we think back, is there anything else that you can think of that this is very familiar with? Well, wait a minute. When we declared variables, we use the var keyword. In this case, we're doing functions, and we're using the func keyword. So we can kind of see the pattern here. Var, short for variable, func, short for function, and that's how we can kind of use that as a memory cue for how do we start out declaring our function. Then we're going to give it a name. So just like with variables, here we say function add. So this is an add function. And we could have just as easily had var gravity, and that was the name of the variable, var being variable, gravity being the name, here func being function, add being the name of the function. And then we have parameters. So these are the inputs into the function. And we don't really refer to them as inputs. Normally when we're coding, we will refer to them as parameters. And in this case, this function is taking two inputs or two parameters. One is an integer that we're going to call a, and another is another integer, and we're going to call that b. So again, analogy to our recipe would be like having two slices of bread coming into our function to make our grilled cheese sandwich. Here we have two variables coming in to this particular function, and we define them here. So we're giving them a name, and then we follow it with a colon and then a type. Additionally, functions don't have to have inputs. So it is possible that this function runs and doesn't need anything to actually do what it needs to do. So in this case, for example, we have a function that basically returns a Boolean, which we'll cover in a second, but we can say this is the name is Monday, sort of like asking a question, and we don't really give it any input. It doesn't need any input to answer that question. And so when we don't have inputs, we just leave the open and closed paren like we have there, but we don't put anything in between those parentheses. Now, it is important to understand that a function does need to still have the open and closed paren. Okay, the func name followed by an open and closed paren is an important part of the syntax, so you can't leave the parentheses out. And then finally, we can look at the outputs that the function has. And in this case, we have the output is also an integer, which ends up being the sum of, we're assuming when we do the statements in here, of the two variables a and b. So in this case, the way we express the output is with this dash greater than, so that's right here, and then we give it the type of what it is we're going to return. So in this case, we're returning an integer, so we say int. And this is how we express the output. Now, just like the inputs, the outputs in the same way don't necessarily have to be there. It is possible to have a function that maybe takes in inputs but doesn't return any output, or vice versa, or in this case, it doesn't take any inputs or produce any outputs. But that doesn't mean it still doesn't do something in your program. So for example, here, this function called clear top score, so wherever that top score is stored, the supposition here is that this function is going to actually clear it. But we don't need any inputs to do that, and we don't need any outputs to do it. And so therefore, we can just leave the dash greater than func off of our declaration completely, and that says that we're not returning anything. Now, all statements in our function are going to go in these curly braces. So every function is always going to start out with an open curly brace. That's that left curly brace right there. And it's always going to end with a right curly brace. And wherever this starts and this ends, all of the statements that make up the function are going to go in the middle. So they all go between those two curly braces. And that really is what we refer to as the scope of our function. Now, it is also the case that you will need, if you are returning something, you will need what's called a return statement. And what a return statement does is it has the keyword return, and then it has, in this case, a plus b is just an expression. We've looked at operators a plus b, so we're adding those two numbers. The result of that is what's going to be returned from this function. So this would be like the result of creating the grilled cheese sandwich. The grilled cheese sandwich is going to come out of the function. Here, the answer to this a plus b is coming out. It is being returned, and we know that that is the case because we've declared it that it is returning an integer. Now, it's also important that whatever you return here from a type standpoint matches whatever you have here. So a plus b are both integers. The result will be an integer. It said here that we're returning an integer, so we're good to go. Now, it is the case, though, that if this were a double or if this were a Boolean, then this would not match and it would not compile. The compiler would complain to us about that. So basically, these need to match. And in the same way, this is just another example of that. If we were returning 9.8 as an example, that's a double, so we would need to have a double there for the declaration. And then finally, in this particular statement or this particular function, this is wrong because we're not saying that we're returning anything here, but we then go ahead and return something here. And that would be illegal. So we don't want return statements if we don't have the dash greater than and the type for the function's output. So now that we've declared a function, how do we call the function? So how do we use it? So the first thing we're going to do is we're going to take the name of the function. That was the add right here. We're going to start with that. Then we're going to do an open paren, and we always want to do that even if there's no inputs. When you call a function, you're going to start with this and then an open paren right here to start calling the function, and then you're going to specify the parameters that go into the call. And in this case, we've got A:3, B:4, and then we close the parenthesis. So what this is saying is that this first parameter A is reduplicated here, and then so is the colon. And then the value that we want to go into the function is the number 3 for A. And for B, we want it to be a 4. So when this function is called, A will be a 3 and B will be a 4. And that's because in this call right here, that's how we've specified those two values. And then finally, we have to look at, well, how do we handle the return here? So what that means is that when add is called, it's going to return a value. So we probably want to capture that value in some way. Maybe we want to put it into a variable. So we can do that by saying result as a variable that maybe we've declared before. And so we can say result equals add. And that means that whatever we've returned here will then go into this particular variable. The other thing is if this is an integer, this should be an integer as well. So if we go up the line to see where var is actually declared, it should be declared as an integer. But remember, whatever is returned here or whatever is specified to be returned here is what's going to end up in this variable in this assignment. So if we look at this during execution, we see that we have the add function, and it's going to, whatever it returns is going to be assigned to result here. So if we were to look at this, we'd say, well, A gets a 3, so A is going to have a 3 here. B gets a 4, so B is going to have a 4 here. So this is going to be 3 plus 4. So this is going to return a 7. And that's how that 7 gets put back into the result. So let's walk through this code. So here we have some code where we're setting up a bunch of variables here, and then we're actually doing some arithmetic related to that code. And that's here in the second block. And then we change some of the variables right here, and then we have another formula here where we print the result. And then we change the variables one more time, and then we have some formulas here, and we print out the result again. And in class, you might have a couple students take the time to actually talk through the code. Say, okay, first var A equals 3, what does that do? B equals 6, and so forth, and they can go through the code. Hopefully, as they do this, though, they're going to see a pattern. And that pattern is that this formula right here of those 3 statements actually gets repeated 3 times. So in this code, we have 3 different places that code was copied over and over again. That means that that's the perfect opportunity to bring that all together into a single piece of code, just like we did here, and turn it into a function. How do we turn it into a function? Well, first we add the function declaration on top of the code. So here we're saying func calc, and we have A and B is our 2 parameters, and we're saying that it's returning an integer. And at the end of this, we know that because we're returning an integer, we need that return statement. So we put the return statement here, and we close it off with a close right brace. So we have open left brace, open right, close right brace, and notice all of the code that's in the function is now between these two braces. This is the proper function declaration for this. So now that we have this function declared, we want to use it, right? So we want to call it. So right here where we have result, we know that we're going to need to actually give result a value based on calling this function. And that means we're going to put code in to actually call the function. So here I have result equals calc, and I still have these name parameters here. So I start out a colon matching the a colon here, b colon matching the b colon. But this a and b are actually this a and b up here. These are the two values of these two variables that get passed in. And those, when they get modified here, get passed in again. When they get modified here, they get passed in again. And don't be confused by the fact that the variable names are still a and b. The point is that they're just happen to be coincidentally matching. But the point is that you're putting the variable here of what you want to pass in, or it could very much be a specific number like we did before with 3 and 4. So this is how we do that. Now, what that means is that we are calling, when we do this calc right here, we're actually calling this function, and that return statement right here is actually returning back to this variable, and that's how that function is actually working. So if we look at this final code, I guess the question is, why is this better? So what would be hopefully the results of that question? What is it that would make this better at this point? Well, first of all, we can see that the function that we had those 3 statements right there, which was the calculation, do not have to be repeated anymore. They were repeated here and here and here previously. Now they're all in one place. So that makes our code a little more readable. We understand there's a common function there, and it makes our code shorter. And anytime we can do those things, that's a good thing. So I guess the second question is, what else is there an advantage to this by doing? You know, what else is positive? Well, it turns out that if we wanted to change the formula in some way, we only have one place that we need to change the formula, is right here. Rather than having to change the formula in 3 different places, here and here and here, we only changed it in one spot. So that's how we actually take advantage of these functions and have a central place for us to do what we need to do. So that is functions. We talked about what a function is. We talked about why they're useful. We talked about how we create them in Swift. And we've talked about how we actually call them in Swift or use them.